In this video, I'm going to be showing you how to set up the RapidChange ATC magazine with a Centroid Acorn. And this is the third step in the process. So the first step, we actually install the magazine on our machine's workbed. And then in the second step, we wire up the magazine. So if you haven't seen our videos on the first two steps, go ahead and check those out. And also this will be specific to the Centroid Acorn. So we're going to be setting this up in Centroid's CNC12 software. If you have a different control software, go ahead and check out some of our other videos because we've made videos showing you how to set up the RapidChange ATC and other control software as well. Okay, let's go ahead and get started setting up the RapidChange ATC for Centroid's CNC12 control software. And what we're going to do to get started is we need to go to RapidChange's website. So it's just rapidchangeatc.com. And then once you've purchased, you'll be given access to this owner section. Go ahead and navigate to this owner section. And then go to the downloads and go to the Centroid Acorn. And we need to download this M6 script package. So I've already done that. So I'm just going to go ahead and open it, the one that I've already downloaded. And this is what it's going to look like after you download that folder. So the way that the RapidChange ATC system integrates with the Centroid CNC12 control software is through installing different macros. And these are the macros that we're going to be installing. And what we have here is a README file. This is instructions. So if you get lost, you can look at this README file and it'll walk you through the setup. And then we have this folder here. What we need to do to get started is click on this folder. And then what you'll find is a config file. So rc-config.mac. We need to open this file. And this is going to be how we set up the RapidChange ATC and configure it for our machine and then install it into the CNC12 software. What you'll notice is that there are 4 different sections to this config file. There's this first section here, and this is just setting up the RapidChange ATC magazine. The second section is this tool setter. And if you're not familiar with what a tool setter is, it's a really nice little tool that you can install on your CNC, especially if you're doing automatic tool changes. And it's a probe that allows you to automatically compensate for differences in tool length. So as you do tool changes, the different tools you'll be loading into your spindle will have different offsets, different lengths that they stick out from the spindle. So one tool might stick out a little bit farther than another tool, and you need some way to compensate for that. A tool setter allows you to do that automatically. And so what happens is as the tool is loaded, your machine will go and probe the tool setter, and it'll give your machine a reference so that you can set offsets between tools. And this allows you to change tools without having to re-zero your Z-axis every single time you do so. So it's a really nice thing to have, and it makes your automatic tool changes truly automatic. So you don't have to go and zero your Z-axis every single time. So that's the second section. The third section is for the dust cover. And then the fourth section is for the tool recognition sensor. And the tool recognition sensor is just built into the RapidChange magazine itself. So this is a sort of a fail-safe sensor. It's there to make sure that your tool change happens the way that it should, and that when you load a tool, the tool and the collet nut are properly seated on your spindle. Okay, now that we've gone over the different sections of the config file, let's go through this line by line. And look, some of your numbers may vary. They may be a little bit different than what I'm going to be using, but I'll give you an explanation of how you come up with that number for each line. So the first line is number 100, and this is pocket count. So this is just how many different tools you can put into your RapidChange magazine. My RapidChange magazine has 6 different pockets for tools, so I'm going to enter 6 here. Next up is the pocket offset. So this is the distance between the center of one pocket to the center of the next pocket. And RapidChange provides you with this number, and this is just going to depend on what size collet your spindle uses. So for my spindle, I use an ER20 collet, so my pocket offset is going to be 45 millimeters. Now for number 102, this is pocket alignment. So whenever you install your RapidChange magazine, you need to install it either parallel to your x-axis or parallel to your y-axis. And what we're looking at here is a top-down view of the machine bed that I'm installing this RapidChange magazine on. And this is my y-axis, and this is my x-axis. And so we're looking top-down on the machine's bed. This is where the RapidChange magazine is installed. So it's installed parallel to my y-axis. And then back here, this is the tool setter. So you're either going to install it parallel to your x-axis or parallel to your y-axis. and we need to tell this config file where it's installed. For my machine, I've installed it on the y-axis, so I need to go ahead and enter 1 here. If I were to have installed it parallel to the x-axis, I would enter 0 here. Now, number 104 is the pocket direction. So basically, we need to tell this config file which direction your pockets are running. So if we go back into the Fusion 360 file here, remember this is my y-axis and this is my x-axis. This is XY0. So I've set it up so that my number 1 tool pocket is right here. And then this is 2, this is 3. So my tool pockets are getting increasingly bigger in the same direction as the axis. Remember, this is XY0 here. And so this is my X max. My tools are going in the direction of 1, 2, 3, 4, 5, and 6. So that means if we look at this pocket direction from pocket 1 to pocket 2, mine is in the positive direction, right? Because it's starting here and going here. And this is the positive movement, starting here and going here. If I were to have made this number 1 and 2, number 3, number 4, number 5, and number 6, it would be going in the negative direction. So for me, I'm going to enter positive 1 here. But if the numbering for your magazine runs in the negative direction of your axis that you've installed it along, you need to enter negative 1 here. Next up, number 105 is the X pocket 1 machine coordinate. So if we go back into this file here, remember, I've specified that this is tool pocket number 1 for my machine. You can specify this is tool pocket number 1. It doesn't really matter so long as you're consistent with it. But what we now need to do is tell the config file where this pocket is located on our machine. So we need to give it the Y measurement as well as the X measurement, which is this direction. So there's a couple different ways that you could do this. For this installation, all I did was install the magazine, make sure that it's parallel to my Y-axis, and then I probed this pocket, which gave me a very accurate reading. Another way that you can do this is if you go to the RapidChange website, they'll actually walk you through how to manually set this up. So if we come back over here, under the installation tab, magazine installation, they give you really good instructions for how to just manually align your magazine and determine your XY coordinates, machine coordinates for your pocket number 1 position. So go ahead and check that out if you don't have probing capability or maybe you haven't set it up quite yet. But they'll walk you through that process on the magazine installation tab, and it's a pretty easy process. For me, I was able to determine that my X pocket machine coordinates were 29.99 millimeters, and then my Y pocket machine coordinates were 827.56 millimeters. And keep in mind, again, this is not a work coordinate system. So if you're in like G54 or something like that, you want to make sure that you switch over to your machine coordinates tab to take this measurement. And then you also want to make sure that it's in millimeters. So if you set your machine up in inches, you need to convert this to millimeters to enter into this script. Okay, and once we have the X and Y machine coordinates for pocket number 1, we need to go ahead and figure out our Z engage machine coordinates. So this is basically going to be the height at which our spindle engages the collet nuts on the RapidChange ATC. So this is pretty easy to figure out. RapidChange's website does a great job of walking you through how to figure out this number. So let's go ahead and go back to their website. And you can find this on the Z height values explained tab. So if we look here, this is the Z engage height. This is a side view of the RapidChange ATC magazine, and you can see that we have 3 different collet nuts installed. What we need to do is figure out the machine coordinates at which our spindle will touch off on the tops of these collets, these collet nuts. And one thing to keep in mind here is that not all collet nuts may be the same height. So if you have collet nuts from different manufacturers, they may be different heights. And if that's the case, you want to use the shortest collet, so the lowest collet. So you can see here that this one and this one are not the same height, and this collet nut and this collet nut are not the same height. This one would be the lowest, and so you'd want to use this to measure that number. And once you figured out which collet you're going to be using, basically all that you do is you bring your spindle down to a point at which it starts to engage with that collet nut. So you can see here, here's a collet nut, here's a collet nut. what you want to do is lower your spindle over your shortest collet nut to a point where that collet nut starts to press. So you want to just see it move down just a little bit. And then you're going to lower your spindle another 0.5 millimeter beyond that. And that's going to be your Z engage height. So it's the height at which your spindle starts to make contact with the collet. You can see the collet just start to move down and then go a 0.5 millimeter lower than that. Okay, so that's your Z engage height. And again, this is in machine coordinates. If you're in work coordinates, you're going to get an inaccurate measurement. And if your machine is set up in inches, you need to convert it to millimeters. Okay, next up is your Z move to load machine coordinate. So this is going to be the height at which your spindle is going to be moving over your magazine in between tool changes. So how high do you want your spindle to be after the spindle is dropped off one tool and it's moving to load the next tool? And so there's two things that you want to clear in this scenario. First, you want to clear the top of the magazine, but also you want to load your tools into your magazine and make sure that this clearance height is going to clear your tallest tools. So if we go back to the RapidChange website, we want to make sure that your tallest tool will be cleared during these movements. So you just want to go ahead and make sure that you enter a number that will allow you to do that. And again, this is in machine coordinates in millimeters. And the next number, number 109, is a very similar number. This is the Z safe clearance machine coordinate. So this is a similar number to number 108, but number 108 was the height at which your machine is going to move in the Z axis in between tool changes. This is going to be basically for other movements except for probing. So if you look down here, we'll actually set up a number specifically for probing, but this is going to be the safe clearance that you're going to use whenever you're not moving in between tool changes. And one thing to note, for my machine, my Z0 is actually at the very top of the axis. So my numbers are negative because the very top of the axis for me is my 0 point. Okay, number 110 is your engage feed rate in millimeters per minute. So this is how many millimeters per minute your Z-axis will be traveling as it comes down to engage the collet nut to perform either a pickup for a tool or to drop off a tool. And again, RapidChange has really good recommendations on this. If we go back to their website and we go to the speeds and feeds tab, they actually have recommendations. And you can see here that it's dependent on which collet size you're using. So my spindle uses an ER20 collet size, and the feed rate recommended by RapidChange is 1700 to 2000 millimeters per minute. So we go back to the config file. I used 1850, which worked for my machine. But one thing to keep in mind is that this is going to be linked to how fast your spindle is spinning as you load and unload your tools. So RapidChange actually explains why this is in this section. But one thing to keep in mind is that if you set up your spindle to spin faster during a load or unload, you're going to need to change your feed rate to a faster feed rate as well. And so if we look at number 111 next, this is how many RPMs your spindle is going to be spinning as it loads a tool. And number 112 is how many RPMs your spindle is going to be spinning as it unloads a tool. And again, this is something that RapidChange gives us guidance on. If you come back down to ER20, which is what my spindle is, they recommend between 1200 and 1500 RPMs. And one thing to keep in mind is that they also provide guidance for how to figure out what the appropriate number should be. This is something that you might have to play with a little bit to get the right setting for. But basically what you want is as your spindle comes down and engages with the collet nut to load a tool, you want to make sure that the collet nut doesn't move up or down. Like you can't visibly see it move up or down from its resting position during the engagement. So that's the guidance that RapidChange ATC provides, and you can see that right here. And they have a video here if you want to observe what the proper engagement should look like whenever you're loading or unloading a tool. And so you just kind of have to play with these numbers in this range, the range recommended by RapidChange, to figure out a feed and speed rate that allows you to cleanly pick up and drop off tools. And just keep in mind that these numbers are all linked. So remember, if you go back to our config file, if you increase the RPMs at which your spindle is spinning during a load or an unload, you're going to need to increase your engage feed rate as well. And really these measurements might sound a little bit trickier than they are, but you just kind of have to play with it a little bit. So run a couple test tool loads and look from the side and see if the collet nut changes height as the spindle's engaging the collet nut. And so long as it doesn't, you should be pretty good to go. And I found in my testing that the numbers given by RapidChange will get you pretty close. So this isn't too bad. It only took me a couple different tries before I had a clean load and unload. Okay, the last thing that we need to configure is the spin up delay. So this is something that I actually had to ask the RapidChange customer service about. And their customer service is fantastic, super responsive. They got back to me almost immediately. And they explained that this is a pause to allow your spindle to get up to speed after a tool change. And they said that it probably doesn't need to be anything more than 1 second. So I just went ahead and set mine to 1 second. Okay, that is the first section done. Let's go ahead and take a look at the second section for the tool setter. And in this section, we have the first thing is whether or not we want to enable the tool setter. So by default, this file comes with 0 here. If you want to enable your tool setter, go ahead and enter 1. And now we need to go ahead and tell the script where our tool setter is located on our machine. But this doesn't need to be nearly as precise as the numbers up here where we were actually telling the script where our pocket number 1 is. That you have to be pretty close with your measurements. This, all I did was I loaded up a tool that had a sort of a V taper to it. And then I visually aligned it over the center of my tool setter. And then I took that measurement from the DRO in the machine coordinates tab. So for me, it was 29.49 millimeters in the X, and then 1,189.71 millimeters in the Y direction. And then number 119 is the Z start seek. And again, this is in machine coordinates in millimeters. So the way that this will work for your tool setter is that when you want to run the tool setter macro, your machine will move your spindle over the top of your tool setter, and then your machine's going to probe downward until it touches your tool setter once. Once it triggers your tool setter for the first time, it's going to retract a little bit, and then it will probe the tool setter a second time at a different feed rate to really dial in that setting. So this number is the height at which you're going to start to probe downward. So whenever you run that first probe, this is the height your spindle will be at whenever you start to probe that downward that first time. And again, remember, this is a negative number for me because the way that I have my machine set up, my Z-axis 0 is at the top of my Z-axis. And then for the next setting, this is the Z move to tool setter. And again, this is in machine coordinates in millimeters. So this is the Z height at which your machine will move to before it starts to move your spindle over the tool setter. So basically you want this to be a clearance height. You're going to want to make sure that you're going to be able to clear your RapidChange ATC magazine as well as the tool setter, even when you have a tool loaded into your spindle. Then number 121, this is going to be your seek feed rate. So remember, we're going to be running 2 different probing passes on our tool setter. This is going to be how fast your machine is going to move downward toward your tool setter, so down in the Z-axis direction toward your tool setter in that first probing pass. And RapidChange recommends between 250 to 300 millimeters per minute for this initial approach. Okay, number 122, this is your seek max distance. So this is not currently used in the macro, so I'm not going to mess with it, but it would just be how far your machine will probe straight down before it will stop probing. So it's kind of a fail-safe, but it's not currently set up, so we're not going to deal with it here. And then number 123 is your retreat distance in millimeters. So remember, our tool setter, we're going to run 2 different passes. We're going to run 1 probing action down, and once we trigger our tool setter, our spindle is going to retract a little bit. So it's actually going to move up in the Z-axis, and then it will run the second probing pass. This is how far you want your spindle to retreat in the Z-axis. Okay, and next up is your input number. So whenever you set up your tool setter, there are typically 3 wires, sometimes 4. My tool setter actually has 4 wires, but basically you're going to run a positive voltage wire, a negative voltage wire, and then you'll have a signal wire. If you have a 4th wire, typically there's a 2 signal wires, and that is an over travel protection. So if for some reason your machine doesn't trigger on the first signal, then a second signal will be sent. But I'm only setting up 1 signal wire on my tool setter. That signal wire needs to be run back to your controller to an open input. So one of the great things about Centroid is that they provide a ton of different schematics that show you a bunch of different example setups. And if we pull up a schematic from Centroid, and these schematics are all available on the Centroid website, but if we pull up a schematic, we can see here an acorn. and the pinout for the acorn. These are all your inputs here. So you have input 1 through 4 here, and then 5 through 8 here. I set up my tool setter's signal wire on input 8. So I just need to go ahead and make sure that I enter 8 here, input 8 here, and then I'll also need to open up the wizard. So there's a setup wizard in Centroid CNC12 software. And in that wizard, you can go ahead and configure your inputs and outputs. And so you need to enter 8 here, and then go ahead and open up that wizard in the Centroid CNC12 software and make sure that you configure your input 8 for a tool setter as well. Okay, number 125 is your set feed rate. And this is the feed rate that your Z-axis will move on the second probing pass whenever you're probing the tool setter. So remember, when we run our tool setter macro, our machine's going to move our spindle over our tool setter, and then it's going to probe down one time until it triggers the tool setter. It's going to retract, and then it's going to probe down a second time until it triggers the tool setter. This is how fast our Z-axis will move downward toward the tool setter on that second probing action. And RapidChange recommends between 25 and 50 millimeters per minute. So I have mine set to 25 right now. Okay, next up is going to be our settings for our dust cover. And I've actually not set up the dust cover on this machine yet, but this is my second RapidChange ATC installation. And I did set up the dust cover on that installation, so I can go ahead and walk you through what these settings mean. And the first setting is just going to be whether or not your dust cover is going to be disabled. So right now mine's disabled. And then your dust cover is actually controlled by stepper motors. And you can set up those stepper motors to be controlled as an independent axis, or you can set them up to be controlled as an output. Now, for my setup, the way that I'll be setting this up is the Centroid Acorn is what I'm using for my controller. That has 4-axis output, and I'm already using each one of those axes. So I can't really set this up as an axis. I'm going to have to set mine up as an output. But if you were to set this up as an axis, you would just run the step direction and then the common terminal. You would just run the step direction and common wires to the driver board that comes with the RapidChange ATC. And then you just need to specify in the script which axis you've connected to. So if we pull up our Acorn schematic again, you can see here are the step and direction pins for your first axis, step and direction pins for your second axis, third axis, fourth axis. If you were to set this up on your fourth axis on your Acorn, you would use axis A. And if you were to use a different Centroid controller, you'd also be able to set it up on axis B or axis C. Then you would just open and close your dust cover and pull the machine coordinates from your DRO where the dust cover was opened and closed, and enter those here. Now, the way that I'll be setting up this machine is as an output. And so what I'll need to do is go ahead and connect to one of the outputs on the Acorn, and then set that up in the Centroid setup wizard. And so whenever I can set this up, if I am connecting to output 1, I'll enter output 1 here. And then I'll go into the wizard and configure output 1 to work with this. And then your output dwell time is just another pause that you can configure. Okay, last section is the tool recognition setup. So remember, these are sensors that ensure that your tool has been installed on your spindle and then it's been sufficiently tightened. And so the first thing is we need to figure out whether or not we're going to enable our tool recognition sensors or disable them. Mine are enabled, so I entered 1. If yours are going to be disabled, you would enter 0. Then we have the tool recognition zones. So we have the Z Zone 1 machine coordinate and the Z Zone 2 machine coordinate. And these are numbers provided to you by RapidChange ATC. So Zone 1 is the height at which the sensor will determine if a collet nut is attached to your spindle. And then Zone 2 is just the height at which the sensor will determine if your collet nut has fully threaded. And these numbers are based off of the engage height in 107 here. And RapidChange tells you how to calculate them on their website. So if we go back to the RapidChange website, we can go ahead and go to the Tool Recognition Zones tab. And again, we'll see that for ER20, we're told how to calculate this, ER16, ER11. And basically, remember my spindle is an ER20 spindle. So zone 1 is going to be 35 millimeters above the Z engage height, and zone 2 is 40 millimeters above the Z engage height. So if we go back into our config file, we know our Z engage height is number 107 right here. And remember, for my machine, this is a negative number. So we need to add 35 millimeters to this number to get the reading for zone 1. And then we need to add 40 millimeters to that number to get the reading for zone 2. And then the last thing we need to set up is the input that we're using for our tool recognition sensors. So your tool recognition sensors are infrared sensors, and it has a signal wire. You need to run that signal wire to your controller. So on my controller, let's see, where did I run it? I ran it to input 3. And remember, these are your inputs here and here. So I ran mine to input 3 here. And so I need to go ahead and input 3 here. And then I'll need to go ahead and open up the Centroid's setup wizard and make sure that input 3 is configured for this sensor as well. Okay, and once we have the config file set up, we need to go ahead and save it. And then we're going to transfer these files to our control machine. So the computer that we're using to actually control our CNC. I'm actually setting this up on a different computer. And so what I'm going to do is I'm going to save these files to a flash drive and then load those files onto my control computer. So I'm going to transfer those files now on a USB flash drive, and then we'll go ahead and finish up the installation from that computer. Okay, so I'm now on the computer that I use to run the CNC12 software. And I went ahead and I transferred those files. You can see that folder is right here. If we open it up, here are the files that we had been working on. And we need to copy and paste these files into the root directory for our Centroid Acorn installation. And so it's pretty easy. All we do is we go to where our Centroid CNC12 is installed, right click on it, open file location, and just go ahead and copy and paste these files into this location. And you just want to make sure that the directory is CNCM. And so now you can see that we have our RapidChange ATC folder here. And if we go down, we'll see all of our macros. So we have our M6 macro that we just copied and pasted in for the RapidChange ATC. And then we have our M51, 52, 53, and 54 macros that we copied and pasted in from our for our RapidChange ATC as well. And so that's it. We basically have those macros installed in our CNC12 software now, and we can go ahead and use those functions. Okay, before we finish off this video, let's go ahead and take a look at a few basic commands that you can use with the RapidChange ATC. First, you can use the most basic M6 commands for tool changes. So this is the most commonly used command. It's what's used for tool changes. So this means that you would enter T, whatever tool number you want to load, and then M6. So if you wanted to load tool number 2, you would enter T2, M6. And then once you execute that command, your machine will drop off the currently loaded tool and load tool number 2. So this is a command that allows you to drop off a tool and then pick up the specified tool. And if you just want to drop off a tool without loading a new tool, you would enter T0, M6. So this is really handy for running semi-automatic tool changes. Let's say that you want to load a new tool that's not in your magazine. You could just unload your current tool using T0, M6 and then load that new tool by hand. And let's say that you just loaded a new tool and you want to go ahead and store that tool on your magazine. So let's say that you want to store it in the T1 position on your magazine. The way that you can do that is with an M51 command. So you would run something like M51 T1, which would tell your machine that you want to use the current tool and store it in tool 1 spot on your magazine for long-term storage. Then the next macro is M52, and M52 just runs a tool setter macro without performing a tool change. So this is great, again, for semi-automatic tool changes. Let's say that you run a T0 M6 command and your machine drops off your current tool. Then you manually chuck a tool into your spindle. You can then run the M52 macro, which will run the tool setter macro and automatically compensate for the difference in tool length so that you don't have to go and re-zero your Z-axis. The next macro that we just installed is M53, which allows you to, if you don't have a tool chucked in your spindle, to set a reference position for calculating tool offsets. So this is a really efficient way for calculating tool offsets. Just make sure that if you run this macro, that you don't have a tool chucked in your spindle. Then the last macro that we installed is the M54 macro, which just allows you to toggle your dust cover open and closed. And one thing I wanted to mention before we wrap up is that to use the RapidChange ATC system, you have to make sure that your spindle is able to actually spin in the forward direction as well as the reverse direction. And like I said before, Centroid has a lot of really great schematics that are very helpful for setting up your spindle and VFD. Most of you out there are probably using an HY VFD, and if that's true, you can use this schematic from Acorn to go ahead and set up your spindle using your relay board. So you just wire up your relay board to your HY VFD according to the schematic, and then configure your inputs and outputs according to this in your CNC12 wizard. And if you've never used CNC12 before and you're wondering what this Centroid wizard is that I'm talking about, it's just the way that you can configure your CNC12 software. So let's go ahead and take a look at where you can find that. So if we go into our control computer and open Centroid CNC12, and so once we're in the CNC12 software, we just have to go to Utility, go to Acorn Wizard, which is F10, open it up. So from here, you can set up your axes, your homing, you can set up your spindle, you can set up your probe. If you come up here, you can set up your inputs and your outputs. And so this is that wizard that I was talking about. And so once you have your spindle wired up, go ahead and take a look at this schematic. And this will tell you exactly how you need to configure your wizard to run your spindle. So this will tell you on the input section of your wizard, you need to configure input number 5 for spindle OK. On the output section, you need to configure output number 5 for spindle reverse, output number 6 for VFD reset, and then output number 4 for spindle forward. And once you have those things set up in your wizard and you have your VFD wired to your relay board, you'll be able to control your spindle in the forward and reverse direction, and it'll be able to function with the RapidChange ATC.